All right, Lady Ada, what is this?
Hey, we're back. You can get rid of us. It's me, Lady Ada,
Yeah.
Mr. Lady Ada on camera control, doing the show and tell for the next 20-ish minutes. We're here hanging out, seeing what's up in the maker community. What are you hacking, soldering, coding, sewing, crafting, and more? We'd love to hear it. We're in Discord, at the Adafruit Discord, discord.gg/Adafruit. And
it's also a chance to see many of the behind the scenes things that we're doing here at Adafruit. So we're going to start with some of our staff.
Yes.
Say hi to Scott. Scott, what you got going on this week?
Hello. I started working on ESP BLE support again. As folks know, we've had it for quite a while, but it's not been kind of complete as complete as the Nordic port is. So I'm working on that again, and I've fallen in love with GitHub Copilot. In particular, because the way that I debug, especially when it comes to an ESP, is I do a lot of printf debugging. And in terms of printf debugging, it's actually this ESP log print. Now, I know it's flickering. That's a Wayland thing, I think. But let me just show you how Copilot works here. So I got two pop-ups. The first pop-up is the Clang D, which is like the autocomplete from the text editor itself and the Clang language server. But then there's also this accept and reject thing, and that is from GitHub Copilot. Now, it looks to me, and you can't see the full thing, but it's actually not quite what I want. So I'm just going to keep typing, and it's not giving me what I want. But sometimes it does. So let's see if I start doing that. OK, so there we go. So now it gave me almost what I want really quickly. And now I can just go ahead and change it just like that. So I'm really curious about this. This has sped me up a lot, especially in Circuit Python, where it may be like np print. And there's like np plat, blah, blah, blah. It came up with something that was totally somewhat context aware. And it's just a debug print, so it doesn't have to be super exact. You can always modify it in the end as well. So really interested in supercharged autocomplete is kind of where I'm at. I know some folks think LLMs are a lot more than that, but right now that's just been super helpful.
We have a couple of videos where Limor steps, line by line, kind of like as a co-pilot or as a partner, like writing a library together.
Right.
And it's like autocomplete, autocomplete plus, or
right. It's been super helpful. Like Limor and I were talking about this earlier, like this big long function here where it's taking an event and it's flickering, an event and producing like the log for that event, just going from like a macro to the string. That was all auto-generated. It was super quick. Definitely something people should have a tool in your toolbox for folks that are doing this. Yeah. But beware, it makes stuff up. The compiler often finds like, oh, this doesn't quite work. Like this is not a formatting. This is not a formatting character. I don't know why you thought it was, or this is not quite the variable name, or things like that. But
all right. Okay.
Still super handy.
Thanks so much. And if folks are curious about this and more, they can probably catch you on Friday.
Yeah, I may go down that rabbit hole a bit. I'm curious to see how the local LLMs instead of GitHub Copilot will work. So I'm currently recording all of my coding practice to see to be able to compare the different versions of what they would pop up as it's going through. So I'm curious to do that comparison.
All right. Okay. Thanks so much, Scott, and see you on Friday.
Thanks. See you on Friday, 2 p.m. Pacific.
Okay.
All right. Next up, Anne, what you got going on?
Well, I thought I would show a project that I did my senior year at CalTech back before the century. It's kind of interesting. I was able to find some stuff. I had seen some information about a national semiconductor chipset called Digitalker. And it was that same TI timeline where you had discrete chips that helped produce voice. Excuse me, I'm getting over a cold. And you could either interface it to a microprocessor or try to do it standalone. They were marketing it for like talking, multimeters, and some other applications. So for a project, I whipped this up. It takes serial input, RS-232, and then it has here, no, there, audio output with volume, and it's implemented through a 6809 microprocessor with typical circuitry here. And then this is the speech chip and the two ROMs here, which contained hardwired phonemes for various speech sounds, and they have this
Cool.
nice little table about what it can say. And so, what you can't see in here is that it's not like a pre-built circuit board. It's all wire wrap, which was very popular at the time. If you're not familiar, you would have sockets, but they would have these really long legs, and you'd put wire into a tool like this, and then you would, if I could, you can see you would spin the end of the wire onto the leg, and you'd make point-to-point connections that way. So let's see here. I've got a couple extra ROM chips from National. So all the sounds are encoded in these ROMs, and then the chip plays it. So that was my project, and I don't remember what I got. Probably an A, but
I'm sure you did.
But I mean, there's a lot of work to it too. I mean, you're doing,
put on your wall,
and that's upside down. Yeah, but hand-drawn vellum circuits and wire wrap and the whole bit. Writing. Oh, here you go. Writing 6809 assembler code. I mean, it's all back then is in assembly, except for the RS-232 interface. You could modify a serial terminal program to talk to it and elicit things. So I had it where you could type in sentences and it would do its best to speak as long as it knew the words that you were typing.
All right. Well, thanks so much, Anne. Excellent blast from the past.
There'll probably be some more as I dig through some of the stuff I've brought. So over the next 3 or 4 months, if you're interested in that kind of thing, I'll try to come up.
On by.
Mm-hmm.
All right. Thanks so much, Anne.
Thanks, Anne.
Next, Melissa, what you got going on?
Well, I have been working on this code editor here. So I have a window. And one of the things I've been doing is adding what's called raw paste mode. And that is a mode for MicroPython and CircuitPython to communicate that like Thani uses to communicate with it. And it involves a lot less chatter on the serial port that way. And so I've been working on it. It's not quite working, but I have it so I can go ahead and connect to the serial device, and then it connects fine. But when I go ahead and open it and stuff, it's showing like double directories here because the output of the code it's somehow becoming doubled here. So if we look at the terminal, it shows that it was outputting like twice as many items as it should have. And so I've been trying to figure that issue out before I go ahead and propagate that to some more of the file functions, and then we can put that live once that's good to go.
All right, right. And if folks want to follow along or play with this later, where can they check this out at?
The code editor is at code.circuitpython.org. It doesn't have the latest changes here in there yet, but they can play with it. It's a fully working code editor that will work with Wi-Fi, Bluetooth, and USB. I'm updating the USB part of it at the moment.
Okay, cool.
more interfaces.
Yeah, we'll stop back as you had the rest of the support so folks can try it out and kick the tires on it.
For ESP32 especially, and ESP32C6 and C3, it's going to be very popular.
Yeah.
All righty.
Thank you,
Thanks so much,
Melissa.
Melissa. Next up, JP, what you got going on this week?
What's cooking?
Hey, speaking of more interfaces, so this thing here on the left is a little sample player. It just plays back samples you feed it. So I've got a basic drum kit there. This is my interface for driving it with MIDI instead of a typical sequencer or keyboard or something like that. And it's got the 4 reflective optical sensors that can tell when one of these little Lego minifigure head goes in front of it. And so I've been programming a couple of different drum patterns, and this is what one looks like sort of stretched out. This is a kick and snare pattern, and this one is a bunch of hi-hats, mostly over here. And so these are not terribly difficult to take off. I won't do one right here. It takes 30 seconds or so, but you can put a different one on here, or you can just drop these little minifigure heads onto pegs that I have sitting on the belt in some spots, in some cases on all of them. So it's driven by servo motor, and I've got the Feather RP2040 and a motor shield driving that. So when I give this power, it's going to start playing those drum parts over the sequencer or the sampler. It's a little easier to tell what's going on if I just on the sampler mute a few of those channels. So this is just the kick, which is this track up here, and it starts on that white Lego skull. And I'll add in a beat when that one loops around.
I think the audio is coming out into...
Are you able to hear the audio?
Now we can, yeah.
Oh, I wonder if I have one of those noise reduction things that's ruining
Yeah, it's like who's
if it's just,
what raccoon is in your trash?
If it's just going through your mic. Well, here's the good news. In the beginning of Ask an Engineer, we're going to
play one where people can really hear
it. A clip on YouTube right now. I think noise canceling is your beats are getting canceled. Sorry.
Yep, totally bitten by that. Yeah, I should turn that setting off on my audio. Let's see. Reduce background noise. Yeah, let's turn that off.
Yeah, try it again. See what happens.
Here we go. Let's see. If you can hear this, I'll drop in some more snares.
Literally. It's like a carnival game.
So was the echo cancellation also?
Yeah, that's what it was.
Yeah, that's it.
That's the other one. Yeah.
So
yes,
cool.
I've built also a digital file for the Lego side of it, so people can assemble that. But the main components of this are pretty simple, and you can see them a little better here if I tilt it up. Here is our nice little stemma breakouts, which have a little potentiometer for adjusting the distance there. And in some cases, you can even, if you have some of these two-sided Lego faces, these guys are dark enough, I can turn them and it'll mute that. So if you wanted to, you could probably make up some two-sided heads that would allow you to just twist them to turn the note on and off. So little drum sequencer, and the Learn Guide will be coming out soon.
Okay.
All right, thanks so much, JP. And folks can turn in tune on.
Yeah.
Drop a Lego to JP's workshop.
That's right. Come on by tomorrow. We'll be doing
all right,
stuff.
thanks so much.
Good to see you. Thanks, JP.
All right, next up, we're going to go to Brad in Kansas. Brad in Kansas, what do you got going on?
I hope you're in Kansas.
Yes, I'm in Kansas, in Lawrence. So, well, I've got a bunch of board booties. I'm involved in stuff for making controls for model train stuff, and some of the test equipment, some of the boards are Arduino based, and other. Anyway, I received some breakout boards from another company. This is one that the catch is that there was nothing on the back of it to protect the contacts the through-hole parts. So, you know, I get real nervous when I'm at a workbench and testing things out, and, you know, something can move easily, short out. So I made a board that the chessboard snaps into,
Yeah.
and protects the back, gives you a nice smooth surface on the back. So if you want, you can use double stick tape to, you know, stick it on the surface and hold it in place.
That's a good idea.
I also made a little cap that to cover up any of the 10-pin
Keep the dust out too.
That's nice.
And I have for our controls, we use we use some of the 4-pin JST connectors and cables that you guys sell to connect to our actual control, and then we have a little breakout board that goes from that 4-pin connector to screw terminals for the customer to screw their stuff into. And similarly, this is a booty board for that. Protects the terminals, and again, the boards just snap in and snap out if you want them to. It also solved the problem. Occasionally, our controls needed a fifth wire, and so we have a version of the breakout board that includes a single pin for kind of a flying lead to plug onto, and then has a 5-terminal breakout. And I 3D print, you know, that housing, and it's nice because I can, you know, color code that at different colors so they can tell immediately if they're picking up the right one or not. And then also, it provides, I have kind of guides that protect your fingers from, sticking into the, getting poked by the sharp end of the, you know, the connecting pin, and also provide a nice orientation to the square mating connector that you plug onto that. It's hard to find single pin Berg pins or DuPont pins or whatever. Anyway, this is a similar breakout board or booty for the Arduino Uno, and I have a set of 3 different sizes of booties for the you know, half and full proto boards from you guys.
Oh yeah.
So, and then
Boots for all.
What?
Boots for all.
Yep. And this is another test board that I printed not only a backside booty for, but also a front side cover and the front side cover, when it's not attached, looks like this, but I've also got snap-in clear PETG strips that provide light guides for the LEDs on the tester. So just a bunch of things to, you know,
nice,
make wiring a little bit more safe and convenient.
Yeah.
And, because
that was a chore. Well, thank you for showing us. I was excited to learn a boot, all of them.
Yeah.
That's how you'd say in Canada. No, and
Phil's in Canada.
Yeah, well, I think Mark's in Canada. And as you make any more of them, or if you want to share those designs, you know, we do our 3D printing show on Wednesday. Let Noah and Pedro know.
Okay.
All right, Brad. Well, thank you so much for
Brad.
tuning in from Kansas.
Very good.
All right.
Thank you.
Mark, did I get the pronunciation correctly? A boot?
Yeah, though I don't notice myself saying it.
All right.
But yeah, I have
I think
heard
it's
it.
adorable.
All right. Well,
It's
tell
like
us
such a cute
about
little-
your projects.
I boot my project this
Yeah.
week. So this actually came from Ask an Engineer last week when I was asking about being able to measure magnets. So I will share my screen.
Yeah. Let
And
me add it up. There we go.
all right, hopefully this all started. So I got the TLV493D, so 3-axis magnetometer. And what I want to do with this is use it as a wind vane to detect the direction of the wind. This is something I learned in the last week, though, is a lot of magnets that people are used to, the north is on top, south is on bottom, or vice versa, which is what's showing on the screen. So I can, let me turn the magnet as much as I want, but the graph doesn't change because the poles are staying basically the same, and there's only 2 poles, so there's no difference in them. What I found, and unfortunately this magnet's a little bit small because they sent me the wrong ones, there's these types of magnets, they're diametrically polarized. What happens with them is the north and south are now on opposite sides, not the top bottom, but sort of left right as much as there's left right in a cylinder. So when you turn it, you now get the X and Y axis showing a change, which if I turn this fast enough and steady enough, you can tell is about 90 degrees out of phase because X and Y are generally 90 degrees out of phase.
There's some nice sinusoids you got.
Yeah, I spent too much time just spinning this in circles
I know. It's like
before the
in
show.
a video game. It's like how close can you get to perfect 60 degree out of phase?
Sounds like a fun game.
Or 120 degree out of phase signals.
Yeah, so for a $6 sensor, this works amazing when you couple it with sort of a diametrically opposed magnet. It's perfect to tell the rotation of the magnet.
Yeah, it was designed for joysticks that had no brushed parts, so it's like they don't go out of drift, right? Because you have pots on like old video game systems, they eventually start drifting because they're not centered. You'd have to center them somehow. But with magnets, you don't have to worry about that because there's nothing to rub or the magnets aren't going to change the magnetism.
Yeah, it works great. The sensor's great. Thanks so much for the recommendation on it. Now I just have to.
You asked. I was like, oh yeah.
Yeah, there's a couple other sensors out there. So maybe next week if my PCBs show up, there's another one I want to try out. But
this is a good one.
Yeah, this one is definitely cheaper than any others. The other was in my DigiKey cart, so I just kind of had to order it.
Yeah, and this one you could hand solder it if you wanted to.
Yeah. So next is just to build the actual wind vane component and physically hook it up. So hopefully in a week or two, I can show that off.
Yeah.
Magnets.
Come on back. This is a perfect project for that.
Fun project.
Okay, well, thanks so much, Mark.
Thank you, Mark.
Thanks.
Alrighty, that is our show this week. Thank you so much for tuning in. We do show and tell every week, 7:30 p.m. Eastern time. We drop the link in Discord. That's where you can join. You can show retro stuff, projects you're working on, and more. Ask an Engineer starts in just a few minutes. Thank you so much for making this the best half an hour of our week every single week. See everybody next week. Bye-bye.